In this video, we are going to look at graphing the three main trig ratios: sine, cosine, and tangent. This is something that was taught in Algebra 2, so we'll do a quick review on how each of these trig ratios, or trig functions, are different from each other. So we will mainly graph one full period, meaning one full cycle of each of these trig functions. So for sine, it starts at 0 and it goes to 2 pi for its parent function. And so that means the period is a full length of 2 pi. The amplitude, which is the distance from the middle of the graph to the minimum or maximum, will be 1. And the general curve for one full period looks like an S, a sideways S. So that's how I know when I have a trig or a sine function. We want to graph 5 main points for my sine function. And the typical pattern goes middle, high, middle, low, and then back to middle. So we want to plot those 5 points, and then we'll just connect it to make our sine curve. Second graph is a cosine graph. Again, it is also a period of 2 pi, and amplitude will be a 1 for the parent function. It'll also go between 0 to 2 pi for its parent function, and instead of having a S-shaped, it's going to be U-shaped. Okay, starting high and ending high. Again, just like sine, we want to graph 3 main points every time we graph our cosine function. This time it'll start high to middle, low, middle, and then high. For tangent, this one is different than the sine and cosine. The period is actually just pi, and it starts from negative pi over 2 all the way to pi over 2. And it looks like this cubic function graph. But unlike the cubic function graph, it just repeats itself every time you start a new cycle. The amplitude also applies here as well. So you'll see that the amplitude will be, we'll talk about the amplitude in a little bit into the video. So the main 2 things we will be looking at are the amplitude and the period. So again, just like I said in the period, it is the one full cycle that the graph will need to do to complete from start to finish. And amplitude will be half the difference between the minimum and maximum, or I just think of it as the distance from the middle of the graph all the way to the maximum or minimum. These are the 3 general functions of our trig functions. We have an a value that we will need to look at and a b value. The a value will tell you our amplitude, and the b value will help us determine the new period of the graph. There's also one more thing that we will need to do in order to find our graph and plot it properly, and that's the increments. So we want to plot those 5 points, right? So in order to find the distances between those 5 points, we want to split up our period into 4 equal parts. So in order to find the increments, we are going to do the period divided by 4 in order to find the increments that I want to work at for the given graph. So let's look at our first example. We have sine of 4x. So let's first start off by identifying our a and b value. The a value here is 1, and the b value is 4. So amplitude will be 1. And our period can be found by doing 2 pi over b. So in our case here, we have 2 pi over 4, which means we have a period of 2 pi. So we'll finish one full cycle within a period of 2 pi. We want to also find the increments that we want to label our graph so that we can make sure we have it properly labeled out. So the increments here are going to be your period divided by 4. So I'll have pi over 2, and I'll divide by 4. I'm going to do keep change flip to divide this fraction, and we get our increments are going to be a pi over 8. Okay. So I'm going to be plotting 4 increments, and that will help us with the location of our 5 points in order to graph our full cycle within a period of pi over 2. So I'm going to draw 4 tick marks. And by the end of the 4th tick mark, we should have pi over 2, which is the completion of one cycle. So first tick should be pi over 8. Second tick will be 2 pi over 8. Third would be 3 pi over 8. And the last one will be 4 pi over 8. Now, if I simplified this a little bit and reduce my fractions, 2 pi over 8 turns into pi over 4. And 4 pi over 8 will be pi over 2. So it does work out that I have a full cycle within 4 increments with a given increment. So with sine, I know it's going to look like an S curve. It's going to start off in the middle, go up to our amplitude, or our maximum of 1. It's going to go back to the middle, down to our minimum of -1, and then back to the middle. Again, we found our minimum and maximum based on our amplitude. So with those 5 points, I'm just going to now connect my dots and create my sine curve. And that is one full cycle of sine 4x. Let's look at another sine graph. This time we have a different amplitude. We have a -2 amplitude. So A equals -2, B equals, this time it's not 3. You can rewrite x over 3 as 1/3 times x, meaning our B value is going to be 1/3. So amplitude will be a distance of 2 from the middle of the graph. My period will be 2 pi divided by 1/3. Again, that would be like a keep change flip, dividing fractions, and you should get 6 pi for a full period. Finding the increments, we're going to divide that period by 4. And reduce it so that I get 3 pi over 2. So we're going to go at an increment of 3 pi over 2. I'm going to plot my 4 tick marks, and let's start plotting. So the first one will be 3 pi over 2. The second one would be 6 pi over 2. Third will be 9 pi over 2, and then fourth will be 12 pi over 2. We can reduce some of these. 6 pi over 2 will be actually 3 pi, and 12 pi over 2 is 6 pi. Now, this time I have an amplitude of 2, but the A value is negative, so our graph is going to be reflected across the y-axis. So instead of going to high first, we're going to go down to low, and then we'll end at our maximum. Okay, so I'm going to mark 2 and -2 for our amplitude, for our minimum and maximum, and this time it's going to again start at the middle. But again, since A is negative, the graph is reflected. Therefore, I'm going to go to the minimum next, back to the middle, up to the maximum, and then down to the middle. Then with my 5 points, I'm going to connect it and make my S-curve, my sine curve. Graphs look the same from example A and example B, but it's important to see that the labeling is different. So in order for you to get full credit and to have a detailed graph, you need to make sure we label our increments. Otherwise, every graph is just going to look the same, and it's really hard to differentiate between the two. Part C, I have 3 cosine x over 4. So this time, it's not going to look like an S curve. It's going to look like a U curve when I'm done. And I have my A value, that's 3. Meaning my maximum minimum will be a value of 3 and negative 3. And then B, again, x over 4 is the same thing as 1/4 x, meaning our B value is going to be 1/4. Amplitude is 3. And I have my period as, again, 2 pi over 1/4. Dividing that fraction, I should get 8 pi. Right? Increments by dividing my period by 4. And I should get 2 pi. Right. Plot my 4 points on my axis, and I'll label my increments. So starting off with 2 pi, then 4 pi, then 6 pi, and then finally 8 pi. Maximum of 3 and a minimum of negative 3 from my amplitude. And we are going to plot cosine. So cosine starts high to middle to low, middle, and high. Connect my 5 points, and I get a cosine curve. With tangent, I have 1/2 tangent x. My amplitude will be 1/2 based on my A value, and my B value is 1 here. Therefore, there's no period adjustment from the parent function. My amplitude is again 1/2, meaning I'll have a point at a max of at a value of 1/2, and I'll also have a value at negative 1/2, and I'll show that in a bit. I have a B value of 1, so therefore my period for tangent is pi over B, meaning my period is just 1. Again, my increments will be split up into 4 parts. So I'm going to take pi, and I'm going to divide it by 4 to just get pi over 4. Right? Now, like I said before, the period of tangent starts at negative 1/2, and it works its way all the way to pi over 2. Sorry, negative pi over 2 to pi over 2. And the increments are in 1/4, so this should work out that all the ticks between it are in increments of 1/4. Now I have asymptotes running from the beginning and end of my period. So I'm going to draw a dotted line straight through from negative pi over 2 and then pi over 2. I'm actually going to plot only 3 points this time. The first point will be at the origin, and then my other 2 will be based on the amplitude. Now, since my amplitude is 1/2, I'm going to go 1 to the right, but I'm not going to go up to 1. I'm only going to go up to 1/2. So you can think of that as like your maximum point. Okay, we're gonna go to the left and then also go down to -1/2. And you can think of that one as your like your minimum point, like we did for cosine and sine. And I'm just going to connect it again so that you create that cubic function looking graph.